10.2 is graphing a quadratic function using the roots. And specifically of the methods, we are going to be factoring today to find the roots. So if we want to go back to factoring, remember we spent the previous chapter factoring. So this is an a equals 1, so it takes one step to factor. X times x will give us x squared, and then we're finding the factors of -7 that add up to 6. So that would be +7 and -1. Now it does say find the solutions, and there's an equal sign, so remember we set this equal to 0 and solve, and set this equal to 0 and solve. So we get x such that x equals, this would give us -7, and this would give us +1 when we move those to the other side. That is when a equals 1. It takes one step to factor if a equals 1. If you look at this one, a does not equal 1, so we're doing MSG. So we multiply the a times the c, which gives us -12. Find the factors of -12 that add up to 1. So that's actually going to be not 1 and 12, not 2 and 6, but 3 and 4. We want to add up to +1, so it's going to be -3 and +4. The S stands for split the B term. So M is multiply A times C. S is split the B term. So the first term stays the same. The last term stays the same. We split the B term into 4x, +4x, and -3x. And then G is factoring by grouping. So we can take out a 2x here, and we're left with x plus 2. We can take out a -3 here, so we're left with x plus 2. And don't forget, you have to go all the way to 2 sets of parentheses first. So this 2x minus 3 becomes one set of parentheses, and the twins become the other set. We're not done yet, though, because we have to set these equal to 0 and solve. So we add 3 to both sides and divide by 2, and we get 3/2. X such that x equals 3/2, or you can write 1.5, and this guy will give us -2. So you have to know how to factor in order to use this method to graph your parabolas. So the solutions to a quadratic equation are called the roots, or the zeros, and they are also the x-intercepts. So all of those will help us out here. So graphing using the roots and the vertex. So instead of 5 points like we made in the table of values, we are only going to have 3 points in these graphs. We're going to factor first, so factor to find the roots, and then you'll do the vertex formula to find the vertex. So we're doing this in 2 parts. It says using the roots and the vertex. So we get, now if we want to find where it crosses the x-axis, then y would be 0. So we're going to plug in 0 for y, and then that will make it look just like the 5-minute check with the 0 on the other side. So we factor it, x plus 7 and x minus 1, and we find our roots. X equals -7 and +1. Exactly the same as the 5-minute check. Those are the x-intercepts. So we graph on the x-axis, -7, 1, 2, 3, 4, 5, 6, 7, and +1. The vertex is going to be -b over 2a, which we've been doing for a couple days now. So that would be -6 over 2 times 1, which is 2. So we get -3. Now that's only half the vertex. Remember, we have to plug in -3 into the equation to find the other half. So -3 squared would be 9, and 6 times -3 would be -18 minus 7. 9 minus 18 would be -9, minus 7 is going to be -16. So in order for us to fit this on the graph, we're going to have to go by 2s. 2, 4, this is 2, 4, 6, 8, 10, 12, 14, 16. So -1, 2, 3, -16 is going to be here. And then we just connect the two x-intercepts with the vertex. And that's our graph. It takes a lot less time than making a table of values, especially in particular cases when you have fractions and things like that. So let's look at number 2. Number 2 looks strangely like the second 5-minute check. All right, so we're not going to go through all this work again. We know when we factored, so we're going to go back down here. When we factor, we'll just write C the second 5-minute check. And we know that the roots were 1.5 and -2. So we'll plot those on the axis. 1.5 and -2. Then we're going to find the vertex, -b over 2a. -b would be -1. 2 times a would be 4. So here's our vertex, -1/4 and something else. This is going to get hairy. So to make this a little simpler, it's okay with me if you change that to -0.25. And then you're going to plug in -0.25 into this equation. So we get 2 times -0.25 squared, which is 0.125, plus x, which is -0.25, minus 6. So we do 2 times 0.125, subtract 0.25, and subtract 6. And what we get is -6.125. And it's okay that half of it's a fraction, half of it's a decimal, because we'll have to graph it anyways. So -1/4 would be about here, and -1, 2, 3, 4, 5, 6, and a little bit more would be here. So it doesn't matter if it's a fraction or a decimal. Oops. As long as you can eyeball it on your graph, then you're good to go. So we factor it to find the x-intercepts. We do the vertex to find that, and then we connect the dots. Let's try a couple more on the back. If you feel like you're ready, you could try number 3. 4 is going to be tricky, but why don't you all try number 3, see how you do. Push pause here. All right, so we plug in 0 equals x squared minus x minus 6. We factor it to find the roots, finding the factors of -6 that add up to -1, and that's actually going to be -3 and +2. When we solve it, the sign flips when we set it equal to 0. If we were to set it equal to 0, x minus 3 equals 0, add 3 to both sides, we get +3. So those are our roots 1, 2, 3, and -2. And now we want to do our vertex. X equals -b over 2a. -b would be +1, because the negative of b is the opposite of b. It's already negative, so we make it positive. And 2 times a would just be 2. We do another fraction. So here's our vertex. 1/2. This one won't be too bad. 1/2 squared is 1/4. So you could do decimals or fractions here. We'll do decimals, that's okay. So 0.5 times 0.5, 0.5 squared would give you 0.25, minus 0.5, minus 6. And so for this one we get -6.25. So we've got 1/2 and -1, 2, 3, 4, 5, 6.25. When you're doing these, you're never going to get some weird, funky parabola. So your vertex should always be halfway between these 2 points. And if that is not happening, check your signs on these first, and then recheck your vertex. But a lot of times when it's not in the center, it's because we have the signs flipped here, which is changing this. And that's usually the big issue. So go back and check it if it doesn't come out in the center. Now what happens if it won't factor? If we're trying to find the factors of 7 that add up to 6, and it's +7, 1 and 7, or -1 and -7, neither of those work. So if it won't factor, or if you can't get 2 roots. All right? If you cannot get 2 roots, then you're going to have to make a table. And we'll call it a mini table, because it's only going to have 3 points. So all these graphs have 3 points, 2 roots and a vertex. So what we'll do instead, we have to find the vertex to make the table, negative b over 2a. That would be negative 6 over 2 times a, which would be 2, so it's negative 3. So when you make your table, negative 3 will be in the center, but you're just going to do 1 above it and 1 below it. And now I flipped it upside down, but it doesn't matter. And then we plug these values in. So negative 3 squared is 9, negative 2 squared is 4, negative 4 squared is 16. 6 times negative 2 is negative 12 plus 7. Then 6 times negative 3 is negative 18 plus 7. And 6 times negative 4 would be negative 24 plus 7. So we get 4 minus 12 plus 7, so that's negative 1. 9 minus 18 plus 7 is negative 2. 16 minus 24 plus 7 gives us negative 1. So negative 2, negative 1, negative 3, negative 2, negative 4, negative 1. And so we still have 3 points. We don't have the roots. So in this case, it doesn't mean that there are no roots, like it does not cross the x-axis at all. It's just actually crossing in between. And sometimes when it crosses in between, we can't factor it, coming out to something really funky. Okay? Last thing's a word problem. When a football player punts a football, he hopes for a long hang time. So imagine, here's the football player, punts the football, goes, woo, and everything you throw in the air actually moves in a parabolic path. So we can apply that to a lot of things. So a time longer than 4.5 seconds is considered good. If a football is punted with initial velocity of 60 feet per second and his foot meets the football 2 feet off the ground, here's the function. Y equals negative 16t squared plus 80t plus 2. That represents the height of the ball. So the y value is representing the height of the ball, and the t value is representing time in seconds, it says right here. So here's the thing. The vertex tells us almost everything we need to know. Vertex is here, in this case a maximum, and it is in the center of the graph. So if we can figure out what the vertex is, and we know it's in the center, then we should be able to figure out how long it's going to stay in the air total. So let's just calculate the vertex. X equals negative b over 2a. That would be negative 80 over 2 times negative 16, which would be negative 32. And we get a nice pretty 2.5. So that's this. That's your x value. Now, normally, this is your x value here. So the x value is your time in seconds. We actually don't even have to calculate the other half. I will tell you, if we take this x value, 2.5, and plug it back in here for t, because time and the x value are the same thing, we get 102. And that means this x value on your x-axis is time, and that's seconds. And this y value, we said the y is the height, so this is height. We're not really concerned with height, so we don't know if it's feet, but, oh, it does say feet per second, so this would be feet. So it's going to go 102 feet high. Awesome. But how long is it going to stay in the air? So it takes 2.5 seconds to get to the top, and it's completely symmetrical. So if it takes 2.5 seconds to get to the top, then it will take 2.5 seconds to get to the bottom, which means the hang time of 5 seconds And that is good, because it says a time longer than 4.5 seconds is considered good. So you want to remember the vertex is the center. So if we can if we can find out how long it takes to get to the top, then we could double it and find out when it hits the ground. So there you go. We will talk a lot more about word problems, but that at least gets us started.